Welcome to a new optimization problem. A cattle rancher allows 20 bulls per acre. On the average, bulls weigh 2,000 pounds. Estimates show that the average bull will decrease by 50 pounds for each additional bull. How many bulls per acre should be allowed in order to maximize the total market weight? Right? So let's write our primary equation. So let's just think about this. So the total weight, we need a T there. The total weight is the average weight of the bulls, average weight of each bull, times the number of bulls. Right, so now if there are no restraints, you could just keep putting more and more bulls on there, right? And they'd weigh more and more. But every time you put a bull, there's less for them to eat. They're going to decrease by 50 pounds. Right? So we want to find the best number of bulls to maximize the market weight. So our primary equation, and it doesn't have to be anything fancy. Our primary equation, T for total, equals weight times number of bulls, right? So this one is W, this one is B, and this is T. All right? Nothing fancy, right? That's how you find total number of the total market weight. You just weigh all the bulls, right? All right, so we need a secondary equation because there are some constraints. And we need to reduce the number of variables down to just one, right? Not including the T there. All right, so secondary equation actually is going to be two. One has to deal with the weight, right? So it says that on average, bulls weigh 2,000 pounds. Estimates show that each bull will decrease by 50 pounds for each additional bull. So they start off weighing 2,000 pounds. But every time you put a new bull into the pasture the bull's weight is going to decrease by 50 pounds. Right? So it's not 2,000 minus 50. That would be what his weight would be if we only put one bull in there. Right? If we don't know how many bulls are going to be in there. So that's going to be X. Right? So weight decreases by 50 pounds for each bull. So that's where that constraint comes in. The second constraint is the number of bulls, right? So he allows 20 bulls per acre. So B equals 20, but we're adding some bulls. How many? I don't know. X number of bulls, right? So that is, we're adding additional bulls. All right, so notice that we could replace W with 2,000 minus 50x, the weight of the bull minus the loss in pounds per each bull. And B could be replaced with, not the B part, just the 20 plus x, right? Because the number of bulls started out at 20, but now we're adding x number of bulls. So that's going to take care of reducing the number of variables as well as taking into consideration the constraints. So there's one, there's two. I'm going to switch colors just so it stands out a little bit. All right, so now we have T equals 2,000 minus 50x times 20 plus x. Oh, what happened to my 0? Looks like 22. Now you could use, so we're going to have to take the derivative, obviously, to find the maximum. And you could use the product rule, or you could just simplify the equation. I'm going to go with simplifying the equation. So t equals, so 2,000 times 20 would be 4,000 plus a 0, right? So this would be 40,000. And then 2,000x. 50 times 20 is going to be 1,000. So that's going to be minus 1,000x. And then minus 50x squared. We should combine like variables. So t equals 40,000 plus 1,000x minus 50x squared. All right, so there's our equation. Now we're going to take the derivative. So that'll be step 4. I'm going to take the derivative. I'll just put here, take derivative. And then and set equal to 0 and solve. And solve. This scribble was supposed to be an and. There we go. All right, so we have dt. And we could put dt dx. Right? Either way, it's the derivative of the total. Equals, the derivative of 40,000 is 0. Derivative of 1,000x is 1,000. Right? And then minus 100x. Right? So that's pretty easy. Set that equal to 0 and solve. 0 equals 1,000 minus 100x. Add 100x to both sides. And then divide by 100. X equals 10. All right? So that is our critical point. Right? Now, let's do a sign chart and see if that is, because we want a relative max. Right? Let's see if that is indeed a relative max. All right, so let's do a sign chart for the first derivative. Right, so we have 10, and we want something less than 10. How about 5? Something more than 10. How about 15? Right, if we plug 5 into the derivative, we have 1,000 minus 500. That is positive. If we plug 15 into the derivative, we have 1,000 minus 1,500. That is negative. All right, so we can see that we have a relative max here. All right, so since I guess we'll call it, maybe I'm going to write t prime. That's easier for me to write. T prime. So since, we'll call it actually t prime of x. The last video I had to label it something really quickly so I could call it something. So t prime of x. So since t prime of x changes sign from positive to negative at x equals 10. 10 is, I need more space, a relative maximum is what I'm going to write. Relative max. Let's also, that's x, there we go. Let's also take the second derivative to verify this. All right, so we're going to verify with the second derivative. All right, so we have t double prime of x equals negative 100. All right, since t prime of x is, t double prime, since t double prime of x is less than 0, t of x is con concave down on the domain, which supports x equals 10 is a relative max. All right, so we have verified that x equals 10 is a relative maximum. Our last step is to answer the question. All right, so how many bulls per acre should be allowed in order to maximize the total weight? Do not tell me 10 bulls. That was not the maximum. That's not the amount we need, right? Remember that bulls equals 20 plus x. All right, so we need to have 10 more bulls, right? So that would be 20 plus 10 or 30. So let's answer the question. 30 bulls maximizes the total market weight. And I am reminded that my last sentence on my last problem was a little weak. I kind of squeezed in the answer there. You should make it clear and answer in a sentence. So 30 bulls maximizes the total market weight. On the last question, which was back here, I should have, oh, there it is. Hit it twice by accident. I should have said, where I have the dimensions, I really should make that say, it's just that I ran out of space. I should give myself more space. Dimensions that maximize, here, I'll answer that completely. So don't just squeeze it in there like I did, bad me, because an AP grader might not know what the heck you mean. So, but if you say clearly, dimensions that maximize area is a length of 500 feet and a width of 200 feet. Nobody could be confused. All right, so that's the end of this podcast. Here I just wanted to make the answer on the last question clear. Here we answered the question about the bulls. So the total number of bulls to maximize the total weight would be 30. The 20 bulls that are already there plus 10 more bulls. So thanks for watching. If you have any questions, as always, let me know. And bye for now.